This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you through the latest and greatest in data science, without taking ourselves too seriously. This time around, we're looking into the ways AI can improve accessibility, from easier methods to querying data, to personalized ethical codes, to using machine learning for the speech impaired. So recently, Will, I was messing around with building my own voice assistant on my computer. And in the process of doing that, I started looking into more work around natural language processing and understanding the semantics of text.
Mm-hmm.
And it actually led me to this article I want to share with you guys today, which is called Salesforce Creates AI Tool for Talking to Databases, right?
Okay.
And often when we think about, let me check the database, let me ask the database, we're really thinking about a structured query, right? And that's where SQL comes from, a structured query language. But what Salesforce is arguing is that their new AI tool will allow you to ask questions of your database in a natural format.
Can you give an example? What do you mean by natural versus structured?
Okay, so if I want to know how many listeners we have in Oregon,
right,
and I had the database, I would say, select from listeners grouped by whatever, where, Oregon.
Sure. So syntax is important. You got to make sure you spell things right. I'll ask it in a very specific way.
You have to ask it in a very structured way.
Right. Got it.
But if I didn't want to do that, Salesforce is arguing with their new tool, I could just say, hey, how many listeners do we have in Oregon? And that query will get translated back into the correct syntax to then pull against the database and return to me a result.
Super cool.
Yeah. So it's actually a really nice way to sort of democratize and open up the space to people who don't know SQL syntax or don't know any sort of database syntax and want to be able to look at their data or understand it.
Yeah, I think this is something that we talk about. I definitely believe that the future of coding is, in fact, if you look at the history thus far, we continue to abstract, we continue to make it more accessible. And so the more we can do this, I think that's fantastic. I think this to me sounds really challenging, but the goal, definitely a lofty one.
Yeah, it is a lofty goal, and I don't think, I don't think they're saying that they've perfected the system, but what they've created is the system called Seek to SQL, SEQ to SQL, and it's a model that is built on a custom data set they made. So I guess I'll start with the data set.
Mm-hmm.
What Salesforce did, they went to Wikipedia and extracted a bunch of tables,
mm-hmm.
right? Just different kinds of information, loaded them up into a database. And then they used Mechanical Turk to have people label queries for them.
Mm-hmm.
If I want to know XYZ, I want to know how many listeners I have in Oregon, what is the query that I should be using?
Yep.
Label that for me.
Mm-hmm.
Then that labeled data got fed into a deep learning model.
Okay.
And now what Salesforce is arguing is that their model is, better. It goes beyond the traditional deep learning models because it's using reinforcement learning. So I believe we've discussed reinforcement learning in the past here. And for those of you who don't remember, the idea is that you will get a better reward. A model will get a better reward or score from an answer that's correct or an action that's correct, and be sort of penalized for those that are not. So, if you are familiar with SQL, you might think, okay, if I need to know XYZ, there's probably 3 different ways I can structure my query.
That makes it more complicated.
That makes it more complicated, right. And so the reinforcement learning here is ensuring that the model is going to choose the best query and hopefully the most efficient query.
Yeah, it's complicated. So I'm not a SQL expert, right? But there's definitely different ways to parse through database indices and actually aggregate and collect the data, make the call to the database server. But I wonder if they actually took that into account too. That would be a real step forward in accessibility, right? Is if you could just say in natural language what your query or your question is, and not only would they translate it into SQL or SQL code, but they would also kind of optimize it for performance. Maybe that's really a pipe dream, but again, why not?
Yeah, right now I think they're just testing if the output is correct, right? You're actually querying the table you want to query. You're getting the results that make sense for what you're trying to ask, you know, and you're not getting some other random result. Again, going back to sort of that democratization, Salesforce has made their model and their data public. It's all on their GitHub. So you can actually look at their Wiki SQL dataset, which is the lookup between the wiki tables and the SQL queries used to get at them, as well as like the queries that they labeled. So being able to see how the sausage is made in their database or in their data set and also their model is pretty interesting.
Yeah, definitely. I actually was able to spend a little bit of time looking at the GitHub for this. I would encourage listeners to, if you haven't done that before, go. We could put the link in the show notes, but go to GitHub, pull down the code, pull down the data, and to your point about seeing how the sausage is made, it's always fun to kind of translate these high-level articles into what it actually looks like in code and in data. So yeah, staying on this theme of accessibility, I wanted to talk about another article that I was recently reading about ethical codes. This article is by Schaun Wheeler. It's called Ethical Codes versus Ethical Code, like code you write. Get it? It's kind of a pun.
Interesting.
And so the subtext here is why ethical standards don't work and what we can do instead. I liked what Schaun had to say here, taking kind of a contrarian stance. And so what he's saying is ethics, they're definitely important. So he gives all these examples, in fact, numerous examples of past questionable ethics practices that he's had to implement in previous data science roles. So maybe Schaun needs to think about his employers a little bit more carefully. But things like faking data sales numbers or quote unquote torturing data to make it fit, a desired theoretical model. So if someone wants to show exponential growth, how can you change the data to make that exponential growth model appear as though it's the best fit model? Mm-hmm. So we've talked at length in the past about ways in which ethics and data science is definitely important. So I think we understand that. But so his point is that we don't need an ethical code.
Okay.
Yeah, and we've said, and so he's calling us to task, right? We've said on this on this program before that we should have these ethical standards. And so I think he makes a good point, which is to say, these codes of behavior, they're problematic in several ways. Like they're not necessary and they're not sufficient. So they're not sufficient, like just having an ethical code alone, it's not going to change behavior. Huh. But then he says, even more importantly, it's not even necessary. And I think instead, his biggest point that he says is we should have ethical code or ethical practices. And so what he means by that is, to give a concrete example, ways in which we educate in the field should be more closely tied to ethical standards. So have you heard of cross-validation?
Yeah, of course.
Yeah, so exactly, of course. So when you train a model, if you're training a machine learning model and you don't cross-validate or you don't at least use a held-out train and test set, people are going to say, trainee, what were you thinking? Like, this is clearly a best practice in model training. I can't believe you messed that up.
Right.
But we don't, he's saying, when we write our code, when we write what should be our ethical code, we don't say, did you do subpopulation analysis? Did you see how this model affects all the distinct groups in your train set?
Or did you check that your data is even representative of a full sample?
Exactly. Yeah. So I think it's a really good point. I think he's calling me out and basically refuting some of the things I've said in the past. And you know what? He's kind of winning me over a little bit.
I get what he's saying too, especially because when you create, he makes this argument, right, that when you create a ethical code, capital C code, it creates a fence, right? Like, this is the line you can't cross. Mm-hmm. And so people who want to take advantage of that are going to build systems that just border that line, right? And that's just as problematic, really.
Yeah.
If not worse, almost, because you can't quite pinpoint them because they're not on the wrong side of the fence. So what are you going to do about it? And so I like this idea of like our practices, our lowercase c code should be built in different ways, especially if Salesforce is going to help tons of people now start accessing data. Well, okay. What does that mean? Should we be saying that, the way you query a data set should be, refined so that you're abiding by a ethical practice of your coding or practice of your data analytics versus, I should be ethical.
Yeah. And just to provide some more color on that fence building argument that he made, because I thought it was interesting. So this idea of if you build a regulation or an ethical code, uppercase C, to make that distinction, people are going to, try to exploit it, and that's going to cause more harm than good. Mm-hmm. Are you familiar with the term p-hacking?
Yeah.
Do you want to explain to our audience p-hacking or should I?
Oh, yeah. Well, we used to call it stargazing too, right? The idea is that when you're running a model, you want to get the model that's going to have the lowest p-value, right? The lowest probability that this finding is not by chance. And so you're trying to get a really low p-value and a little star on your model that, hey, look at that coefficient, look at that number. It means that I hit something big. And so people will do all sorts of smoke and mirrors, right? You transform this variable, you change something completely in your data set so that it doesn't even make sense anymore. But hey, you got that p-value.
Exactly. Yeah. So in terms of fence building, I mean, you've done it, I've done it, and by exploit, I don't mean that, just written papers and been aware of p-value and significance thresholds.
Oh, yeah.
So oftentimes in the literature, 5% is kind of this holy grail, this really important number. So if there's less than a 5% chance that your result was due to a random noise, then people say, okay, 4%, wow, this result is legit. It's really good. Yeah. Whereas if it's a 6% chance, people write you off, you're not published, all hell goes loose. Right. So I think that in this case, as you said, people game the system. It's a fence, it's a regulation, it's being exploited, and it's really causing a lot of problems in social science and science more broadly. So I think his idea that, really it's up to the practitioner, it's up to these more day-to-day concrete practices, like, we should be thinking about unbiased ethical code the same way we're thinking about best practices with regards to model training. I think it's a point well taken.
Yeah, and I think something that we talked about, on the first episode was, why aren't we learning these things in data boot camps and machine learning books and all of that, right? We go through a lot of effort to learn the intricacies of models and like SVD and gradient boosting and what have you, but we never really talk about what does it mean to do something, to run a model that predicts whether people are going to default on their loans or not, or, to run a model that could potentially be harmful to a lot of people. So at least bringing that back into the conversation. So I know that you're being a little bit won over here by this article, but I do think that it's still important for us to be able to acknowledge like broader ethics of our data, even if the way we implement it is in the code itself and not as like a guiding set of principles.
Yeah, I mean, I think he's also just saying, we don't need to rely on like one large bureaucratic institution, but instead just these minor like local policies, so to speak, are more, the way forward. So cool. I think it's a good point.
And now it's time for In English, Please, the part of the show where we talk about complex data science questions in English. So today, Will, can you please explain BERT to me in English?
Yeah. So BERT stands for Bidirectional Encoder Representations from Transformers.
Wow.
So we've got our work cut out for us today. But the audience can think of this as a neural architecture for language modeling. So we're in the NLP space here. And again, BERT was really a major step forward in us being able to understand language computationally. And so there are a bunch of big contributions here. So the first one that jumps out at me is pretty cool is this idea of access to data. So BERT is what I would call both a unsupervised and a supervised learning program. So to do this, they basically can just scrape all of the text on the internet. So in that way, it's unsupervised. You don't need to go through with Amazon Mechanical Turk, for instance, and actually label data. We can just take books, blog posts, whatever text has been written that we think is reasonably coherent English, we can use that. And then for the supervised piece, the way we accomplish that is by masking words in a text. So if you think about the sentence, Will made a deposit at the bank and then he biked home, we might mask or take out words to help train this model. So we might actually say, Will made a blank at the bank and then he blank home. And so in this case, we've taken kind of an unsupervised way text that exists on the internet, and then we've created a supervised learning problem where we know the true answers are deposit and biked, but we need to learn them, quote unquote. And then two other ways in which BERT really contributed to the NLP space. One is attention, and the other is bidirectionality. So in terms of attention, this is a way for a natural language model to essentially consider context. So if we think about Will made a deposit at the bank and then he biked home, who do you feel like he is referring to in that sentence?
Will.
Will, that's totally correct. So it's obvious to you, but in a natural language system, that's not super trivial to implement and understand. And so the idea of an attentional transformer, basically it's a computational way for us to, as we're looking at individual words in a sentence, also maintain an understanding of the other words in the sentence. So in this case, when the model comes to the word he, it's in a sense looking at all the other words, and it's really aware that he is associated with Will. So that's, contribution number one. Contribution number two is the bidirectionality of BERT. And so as it says in the title, it's a bidirectional encoder. And so if you think about the sentence, Will made a deposit at the bank, if we're just reading from left to right, Will made a doesn't really tell you that much about what should come next. Whereas if we read from right to left, So bank the at blank. Once you see bank, something's happening at the bank. Now that's a really great clue to the fact that the correct verb there maybe should be deposit. So actually implementing this bidirectionality, it's not so trivial because if you think about it, you can read something left to right and right to left. You can kind of cheat and look both ways. But I'll direct our listeners to the paper to really get into the weeds as to how this all works. But those are the two big contributions, I would say, attention and bidirectionality, and how BERT has really made a big leap forward in NLP space.
Thanks for explaining that in English. For the last article today, I want to talk about a new study that came out in the international journal Nature. And it's actually about using artificial intelligence to translate brain signals into speech. So imagine people who can't speak. Right now, folks use a technology that allows them to control a muscle, maybe in their face, maybe it's their eyelids, and they use those muscles to communicate to a computer letters that then get spelled into words, and that can be really slow.
Mm-hmm.
So researchers have actually found a way to take brain signals from electrodes implanted on your brain and convert them into actual sentences using like a speech generating algorithm.
Talk about accessibility,
Right.
what that application of AI would do. Tons of good for sure.
Oh, absolutely. I mean, what's really exciting about this development is that previously researchers were able to take readings on brain activity and translate that into a single word, right? Like a single syllable word. So you think cat, and the electrode is able to see that activity in your brain and associate it with the word cat. But now they've been able to do full sentences, right? And so what they did to make this work, so they sat people down and they said, hey, go ahead and read these sentences out loud. But not only did they record the electrical activity in the person's brain while they were reading the sentence, they also recorded how their mouth and their jaw and everything was moving while they spoke.
Okay.
So then using data, like prior collected data on what sound vibrations are produced when the mouth and the throat and the larynx move in a certain way, they use that data in conjunction with the electronic data from the brain signals to create a model of predicting a sentence based on the brain signals and the movement of the mouth.
That's super cool. It's also surprising. I guess it's kind of illustrates how poorly we still understand the brain, right? Because if you think about it, the ideal way to do this, as far as I can tell, and I'm definitely not knowledgeable about the brain or neuroscience, but there are synapses firing, and that's emitting an electric signal. That's a signal that we should be able to convert using a machine learning algorithm to noise. So in this case, we should be able to say, take this synapse signal and then output audio. But it's so weird that we're going from electric signals in the brain to muscle movements to noise, right? Like we're adding in another layer, which seems inefficient, but maybe that's just what we have to do because we really don't understand the signals that are coming from the brain, right?
Yeah, well, they claim that being able to do sound analysis from movement plus brain activity is easier than just straight brain activity to a certain sound. And obviously it's because we don't understand the brain fully yet. But I love the sort of the application to AI where you think about we've created neural nets based on the brain, right? And how we process things. And now we're trying to like sort of use that against itself to create a neural net on a neural net to understand human thought. I mean, it also is interesting because it links into what BCI is doing now, right? Like this is the Elon Musk stuff where they're implanting chips into people's brains and then using that to sort of create like an augmented human experience.
Yeah, so for those who don't know, BCI standing for brain computer interface.
Yeah.
So super sci-fi type stuff, but if you're interested in data and data science and AI, it's kind of like the holy grail, right? It's like getting that high resolution data from the brain and then understanding it. And then, yeah, I think my understanding of what some of these BCIs are trying to do is not only interpret data that's coming from the brain, but also then send signals back to your brain, right?
Right.
So communicate with it.
Yeah, I mean, I think that link between the human and the AI, right? Like we always think about AI as being like outside of us. It's like robots who are going to take over the world or whatever it is. But what about the AI that's going to integrate literally into our bodies, right? Because we have AI integrated into our day-to-day already. But like something like this neural processor or even BCI, it's physically implanted on you.
Yeah, it's interesting thinking about the kind of the physicality of this application of AI, and we've spoken previously about Centaur AI, so Centaur decision making. So you have some sort of AI decision maker that understands data and then gives you a response about a decision you might want to take in the world. But then we said in Centaur decision making, kind of the ideal, at least at the moment, is to have a human understand the AI's output and then judge for itself. And so now, I guess to your point here, this is also a different sort of AI Centaur.
Yeah, I mean, it's one of these, futuristic AI sci-fi things that we've read about, growing up as kids maybe, but now is very much on the horizon. And going back to the ethical codes, maybe when you're getting people's brain data should be really locked up tight, and not get leaked, or, there should be like a doctor patient AI confidentiality pact or something.
Yeah, I mean, it's tricky, though. It's probably a little bit frustrating, at least to me, because I do think that open source is a great way for particular software technology developments to accelerate. And so I think you make a very good point that, yeah, we want to be careful with the data, but then also if this brain data and this audio data is so restricted, then it's just a small subset of medical researchers who are relying on to advance this field. So kind of a catch-22.
Yeah.
Well, we'll see where this ends up.
Yeah.
But thanks for sharing.
For sure. Before we head out, it's time for the banana fact of the day. So the average American eats about 27 pounds of bananas a year, or about 90 total bananas a year. For comparison, the average American also eats around 30 pounds of cheese a year.
That's bananas. I definitely eat way more cheese. That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.